some of you just know it, but right, because the left of the mean is what? 50% or half, right? So, but you could look it up. It's in, if you look up a z-score of 0, it's in there. If you go look up 0.00, it's right there, 50%. So how then do I find the area that I'm looking for? Right, because this whole area is 7764, and I only want this little bit. I don't want that bit included. So I need to subtract the 50% to get the area that I'm looking for. The bit in the middle here. I just want this bit. So I subtract to get 0.2764. Anybody have any questions about the betweens? All right, I'm going to move on so that you can, we'll stop and practice some. No, we'll practice a little bit, and then I'll move on. We'll practice a little. So the mean is 80, correct?
Yes.
And the first one says less than an hour. So that's my step one, less than 50%. So I have the standard deviation is 10. So I do a z-score. I do 60 minus 80 divided by 10 is -2. -2. It's most helpful if you write your z-scores to 2 decimals, because that's how you look them up in the booklet. Okay, so we've done step 1, draw and shade, think of a sensible answer. Step 2, calculate a z-score. You now go to your booklet. You go to -2.0 here and 0.00 here, and this tells you 0.0228, right? And step 4, you don't have to do anything, because this table tells me the area to the left, and that's what I want. So now I'm done with part A. And I think everybody got that. In part B, you're asked, I believe, from 60 to 75. This area in here, correct? So I already know that this has a z-score of -2.00, don't I? So I need to calculate a z-score for the number 75. 75 minus 80 divided by 10. This has a z-score of -0.5. Everybody with me? In my booklet. So I know already that the area from 60 to the left is 0.0228. Now I go into my booklet to -0.50. What is this number here? Did everybody find that number? So that represents the area from here all the way to the end is 0.3085. But I only want this area. I don't want all of this. I don't want 30.85%. I want this bit. So how would I find that part? Subtract, right? Because I want the 30.85 less the 2.28%. So to get this area in here, it's 0.3085 minus 0.0228, which is 0.2857. Does that make sense? I don't need to subtract anything from 1 unless I want the areas to the right. Okay, in part so this is about time on a test. The average time it takes a student is 80 minutes. It says the class is 90 minutes long. And I think there are 60 students in the class. And it wants to know how many students want longer on the exam. If you want more than 90 minutes on the test, you're going to run out of time. Right? And how does the question word it?
How many students do you expect will be unable?
So assume the class has 60 students. The examination period is 90 minutes in length. How many students do you expect? Well, first we need to find out the probability, right? So I need to find this area who can't finish. Okay, so I've drawn in shade. Think of a sensible answer. What?
Under 50%.
Less than 50%. Less than 50%. What's step 2?
Find the z-score.
Z-score. 90 minus 80 divided by 10 equals 1. So this is plus 1.00. Then I go to my booklet. 1.00. What does it say here?
0.8413.
Is that the answer for that shaded area?
No.
That would be a stupid answer. That area is always given, it's cumulative, it's from that point all the way down. Is 0.8413. So what is the area I'm looking for?
1 minus 0.84.
Now I do the 1 minus. Because I want the area to the right. 0.1587, right? 15.87% of the students cannot finish in time. But the question didn't ask what percentage. It asked how many. So if 15.87% of students can't finish, and there are 60 students in the class, how would I
multiply?
Multiply it by 60. And I get something like 9.52. Right? Students. I don't round it because remember, some classes it'll be 9, some classes it'll be 10, but average out at 9.52. 9.5 students. Okay?
You said don't round?
No, don't round it to a whole number. Okay? All right, so I'm gonna move on, and then again, as I said, on Thursday, I'm not gonna do any lecture. I'm just gonna work with those people who are working on their packets. So if you've done your packet by then, if you get this and you've gone all the way through and done it, show it to me and you'll be good to go. I want to get all the teaching part done today. Okay, so here's where I'm going to kind of rattle your cage a little bit. So up until now, I've been giving you the number, and you've been calculating the z-score and finding the area, right? That's what I've been doing. I gave you what's the probability it's between, 60 and 75 minutes. What if I did it backwards? What if I give you the probability and ask you for the number? For example, when you take an SAT or an ACT, Stanford won't look at you unless you're in the top 5%. The number varies, right, when So like you need to be in the top 5%. In a lot of sales jobs, a lot of people go into pharmaceutical sales. If you're in the top 10% of the team, you go to Hawaii. Okay? So they have to figure out where's the top 10%? Where's the cutoff, right? So if I'd say, I want to run the exam so that I don't want 15, almost 16% of students not to finish. Maybe I should make the exam time a little bit longer, right? If I wanted, like maybe only 10% not to finish, how long should I set the exam? Okay, so you would be able to do that, but you've got to do this backwards. Here, I gave you the numbers, and you found this. Now, I've given you that, and you've got to find this. So the way you do it is with a z. First, you've got to find your z-score before you can find your number. So if this is 0.1 over here, what is this area right here? 0.9. That's an area, correct, or a probability. So now I need to go to my booklet. So go to your booklet and tell me what z-score that would, first of all, would that be a positive or a negative z-score? A positive, so make sure you start on the positive page. Okay, so starting on the positive page. And what z-score would be associated, I've got to look up the 0.9, not the 0.1, because it's not a magical book. It only tells you the areas to the left, right? So I've got to look up 0.9.
1.29.
So these are the z-scores out here, right? And these are the areas in here. So you've got to look for the number closest. Like, is it this, Brandon?
Yeah, 1.28.
Yeah, this is 1.28. And what's 1.29?
0.9.
Okay, which one's closer?
0.8.
This is the closest to 90%
I see.
that you can find. Right, when you are given an area, these are the areas. These are the z-scores. We looked up z-scores to find areas before. Now we're going to look in areas, and they're not random. The numbers in here are in order. So you look in here, because you've got an area, what you need to find is the z-score. This number right here has a z-score of 1.28. Okay, so we know the mean, I'm just making this question up from that number 1. So the mean was 80, right? And the standard deviation was 10. What's a z-score? Tell you again?
The standard deviations.
How many so this number is 1.28 standard deviations above the mean. So there's a couple ways you can think about it, right? We have this formula, the number minus the mean divided by the standard deviation. So we could say 1.28 equals x minus the mean divided by the standard deviation, and you could use algebra to solve for x, right? Or you could say this number is the mean plus 1.28 standard deviations. It is the mean plus 1.28 standard deviations. This is 92.8. So if I added like 3 minutes to the exam, then I'd have 10% of the students not finished. See how I did that kind of backwards? I'm going to do another example. That's one I just added to you. Okay, so in these types of questions, it will say what number, the kind of question this would say is, what number cuts off the top 10% from the bottom 90? Okay, so I looked that area up in the area of the table, and then I read off the corresponding z-score. It makes you think backwards. This question says, PepZone sells auto parts and supplies, including a popular multigrade motor oil. When the stock of the oil drops to 20 gallons, a replenishment order is placed. Okay, so they say, okay, we've got 20 gallons left. I say, fine. I'm going to call and place an order for a new shipment. Okay, so when I get down to 20 gallons, I place an order. The store manager is concerned that sales are being lost due to stockouts. That means you run out of stock before the next shipment comes in. So you sell all 20 gallons you got left before the shipment comes in. It has been determined that demand during replenishment lead time, okay, Lead time is how long I have to wait from when I call and say, hey, send me more oil until it arrives. That's lead time. How much notice do I have to give? It could be 5 days, could be 3 days, could be 2 weeks, right? How long is it from when I place the call to when I get the delivery? That's lead time. Demand during lead time is normally distributed, bell-shaped, with a mean of 15 and a standard deviation of 6.
The positive, I mean, there's not gonna be enough, for 3 standard deviations on the bottom side.
Right. We're gonna run out.
Yeah.
We're gonna run out.
So is it asking us basically to,
Well,
With the
the
new
next
standard-
question is on the next
Oh,
page,
okay.
I think. So to draw what this looks like, so demand is normally distributed with a mean of 15 and a standard deviation of 6, right? So the question is, what's the probability of a stock out? What's the probability of running out of stock? Okay, I run out of stock if demand is more than 20 gallons. Because I got 20 gallons, right? So if demand's 21 gallons, 24 gallons, I'd say, I'm sorry, I don't have any. I've got new shipment coming in. Don't people tell you that all the time? Oh, come back, I'll be in next time. So the probability of a stock out is whatever the probability of demand being more than 20 is. So a lot of the hardest part of this is you're going to take the question and see what they're asking you to do. So what is a stock out? It's running out of stock. Why am I going to run out of stock? I'm going to run out of stock if demand is more than what I got on hand while I'm waiting for the shipment to come in. Okay. So there's your step 1. Draw and shade. Is a sensible answer more or less than 50%? Less than 50%. Okay. So draw and shade. Oh. That's what it looks like. Oh, I went too far, I think. I put a Z-score on. Okay, draw and shade. Okay, so I need to calculate a Z-score for number 20. I do 20 minus 15 divided by 6. It has a Z-score of 0.83. That wouldn't be a stupid answer for an area, would it? That wouldn't be a stupid answer for this area, would it? 0.83? That's why you've got to keep your numbers on one line, your Z-scores on another, and your areas in another, because that Z-score is an awful sensible answer for that area. Because this area to the left is more than 50 here, right? But that's a Z-score, because you did 20 minus 15 divided by 6 is 0.833 recurring, but we just do Z-scores to 2 decimals. That means this number is 0.83 standard deviations away from that. So then you go to your book, and you go to 0.83. What is that number here? Seven, 9, 6, 7. Is that a sensible answer for this area? No, because that's the area to the left. 0.7967. So how do I find the area that I'm looking for? I subtract it from 1. So here's the booklet. Everybody find that in their booklet? 0.7967. Okay. So this is doing what we were doing earlier. This is not the new stuff yet, right? This is just the old stuff that we were doing. Just looking up a Z-score, right? I told you 20 and you tell me then the area to the right is 20.33%. So every time I place an order, there's a 20% chance that I run out of stock before it comes in. That's probably not a good business model. So, if the manager wants the probability of a stock out to be no more than 5%, what should the reorder point be? Okay. This is where we're going to, both parts being hidden. So we need to figure that out. He wants there to be no more than a 5% chance of running out of stock. Okay, so we know the demand is 15, agreed? We know the standard deviation is 6, and we need to know when should we place an order, so that this is 5%. We don't want to run out 20% of the time. We're willing to run out 5% of the time. Why do I want to, like, never run out?
More stock.
Yeah, why don't I just keep, like, 500 gallons? Inventory is expensive. I might spill it. It might expire. I might buy so much that I need to now rent a warehouse and pay for that. Didn't I tell you that one of my students calculated in their old exam to order light bulbs, and she ordered me 150 years supply? And I wrote, I sure hope I'm not there when the delivery comes. I'm gonna have to rent a warehouse. You just ordered me 150 years worth of light bulbs. Light bulbs change. Light bulbs have changed from those like fluorescent tubes to LEDs, and right? So you don't want like unlimited amount of stock. You don't want to 100% of the time be in stock, because that means that most of the time you got a lot more stock than you need, and stock's expensive. You have to pay for it up front and ties up your money. So you might be willing, now how you're willing to be out of stock, this depends on what type of business you run. Are you a high end? Then you might want this to be 1%. You don't want to run out very often when you got high end customers who are paying premium prices for good service to come in and say I'm out of stock. Right? So this varies on what type of company you are. So I need to find this number. How would I find this number? Well, first I gotta find the z-score, right? How do I find the z-score? Well, I need to know the area to the left. What is the area to the left? 95, 0.95. What z-score goes with an area of 0.95? It is a very famous one that in a week or two it is going to roll off your tongue without even looking it up. Let's see, alright, here's the, okay, so what is the z-score? So we go into our table. You go in your tables, you look for the number closest to 0.95, right? Because we want top 5, we want the point that cuts off the top 5% from the bottom 95%. So we're looking for 0.95. It is exactly halfway between these two numbers. Usually we pick the closest, but it's exactly in the middle. Therefore, we average 1.64 and 1.65, and we use 1.645. If you don't do that on your home, it's a very common one. Like you're gonna know 1.645 off the top of your head very soon. If you don't use it on the test, if you used 1.64 or 1.65, I will be okay. But on your homework, it won't. Okay, it needs you to use 1.645. I've been bitten twice right down here. And I scratch until they turn thick, and I get big welts. I might have very weird reaction to them. All right. So we're going to use 1.645 as this z-score right here. This is the z-score, and which way you solve it, I don't really mind. Whichever way I showed you. Right, 15 is the mean. This number is 1.645 standard deviations above, or you can use the z-score formula. So the z-score formula is x minus the mean divided by the standard deviation. So you could put 1.645 equals x minus 15 divided by 6 and use your algebra to solve it. If you think in that formula way, that's one way. The other way is this number is 1.645 standard deviations above the mean. So I do 15 plus 1.645 standard deviations. They would give you 24.87. So you would probably tell your boss to reorder when you have 25 gallons of oil left. So that makes you think backwards, doesn't it? All right, now I'll do a real quick one here. Okay, so this says, I like the black marker, it won't select that. All right, demand for a new product is estimated to be normally distributed with a mean of 200 and a standard deviation of 40. What's the probability demand will be less than 100? Okay, so this is what we were doing at the beginning of class. Okay, so I've done step 1, draw and shade, and my sensible answer is less than 50%. I calculate a z-score in step 2, and I get negative 2.50. I go to my booklet, I look it up. What do I look up? Negative 2.50. What is the area to the left?
.0062.
0062. Everybody find that? 0062. That's the answer, because that's what I'm looking for. Okay, then B, it says what's the probability it's greater than 250? Less than 50%. I do the number minus the mean divided by the standard deviation, 1.25. I look that up in my table, and what does it tell me? .25, I get 0.8944. Then I need to subtract it from 1 to get the area to the right. Yes? Okay, between 210 and 220. 210 minus the mean divided by the standard deviation. This has a z-score of 0.25. 220 minus the mean divided by the standard deviation. This has a z-score of 0.5. These are z's, these are numbers. If you look up a z-score of 0.25, what's the area to the left? 0.5987. And the area to the left of 0.5 is what?
0.6915.
So to get this area, I'm doing 0.6915 minus 0.5987. Do you agree? Which is 0.0928. And the very last part says, what would demand have to be to qualify for the top 10%? We've already looked this one up. Okay, when you're looking in your table for the number closest to 0.9, we found 0.8998 gave a z-score of 1.28. Bless you. So to find this number, right, and the mean's still 200, standard deviation's 40, you would do 200 plus 1.28 times 40. Or you can do the z-score formula and use algebra. So 1.28 equals x minus 200 divided by 40. Okay. All right. So we'll do more if you come on Thursday and stay, we will do these problems and we will finish the packet. If you've got it, prove it to me that you got it and you can leave. But I want to work with those people who this takes a little bit more time.
Thank you.